Good morning, respected teachers. Today, I, Roshika Tandon of M.TECH second year, is going to give a presentation on the topic Comparative Analysis of Regression Techniques for Predicting Air Pollution. This is my presentation outline, which comprises of abstract, introduction, problem statement and motivation, literature survey, proposed methodology, experimental results, conclusion and future work, and references. Coming to the first slide. With the increasing air pollution, the quality of air is adversely affected due to various sources like automobiles, burning of fossil fuel, gasoline, consumer products, etc. Traditionally, the air quality prediction methods count on the numerical data and involve more computational power for the assessment of pollutant concentration and thus spawning an unsatisfactory outcome. But now, the effectual of forecasting air quality has significantly changed by the formation of IoT based sensors. There have been numerous machine learning and deep learning based approaches explored for air quality forecasting and monitoring in smart cities. This study represents a comparative analysis of four different regression models for the pollution prediction and also to find out the best model based on the performance evaluation. The parameter nitrogen dioxide has been chosen in this work. This study has conducted the experiments in Python programming language with Spider 3.7. R squared and root mean square error have been used as evaluation criteria. Coming to the next slide, introduction. Air pollution has presently become a major problem for both the developed and developing countries due to the quick evolution in industry and transportation. When the dangerous or harmful substances, including gases, particles, and biological molecules, are launched into the Earth's atmosphere in extravagant quantities, air pollution occurs. One of the biggest problems in air quality control is the lack of precise monitoring. This issue can be resolved with the help of IoT. IoT is basically a webwork of substantial objects that accommodate electronics embedded within their construction so that they can convey and recognize the relations among each other and with esteem to the peripheral environment. There are numerous modern applications of IoT like smart grids, smart cities, smart home, and many more. There are various sensors that are used to calculate the concentration of pollutant, like electrochemical sensor, catalytic sensor, solid state sensor, and many more. This the development of portable, small, and cheap sensors are used to measure and report air quality with great accuracy and with low data rates and long reach. Extracting and retrieving the hidden knowledge from IoT data received from the sensor devices is a challenging task. So, to overcome this problem, a machine learning model and deep learning models has been proposed. In our work, we are using regression, which is a supervised machine learning technique. Machine learning is a type of artificial intelligence that makes system or computer work independently with no human intrusion, and it allows system to obtain knowledge without any explicit programming. Coming to the next slide, this figure depicts how machine learning algorithms are useful in predicting the values of pollutants. Machine learning based and deep learning based algorithms are used to build the forecasting models by learning from the collected data. By performing the experiments on the data and by evaluating the results obtained from these experiments, these models predict the concentration values of pollutants. Coming to the next slide, air quality evaluation. Air quality evaluation is a prime procedure to observe and manage air pollution. The substances that are responsible for causing air pollution are called air pollutants. Pollutants can be classified into two types. The first one is primary pollutants. These are the substances which directly emitted from a process such as sulfur dioxide released from factories. The second one is secondary pollutants. They are not emitted directly. There are various types of air pollutants like PM 2.5, ozone, nitrogen dioxide, carbon monoxide, sulfur dioxide, and lead. Coming to the next slide, Air Quality Index of India. An essential indicator to study and evaluate air quality is the Air Quality Index. The government organizations uses AQI so that they share with the public how polluted the air currently is or how contaminated it is predicted to become. The overall quality of the air is computed by AQI on a scale with a range from 0 to 500. The range is divided into 6 levels as shown in this table. These levels show the influence on the human health. A good air quality is represented by a low number, while a worse air quality is represented by a high number. Coming to the next slide, problem statement and motivation. Air pollution is a major issue. It becomes a vital concern in India, which ranks even higher than smoking, rise in blood pressure, and also comprise of the risk factors for the diabetes. There are long-term and short-term health effects caused by the air contamination. Also, the acid rain is caused by the air pollution, which damages the soils, wildlife, rivers, trees, etc. It contributes to the premature deaths of 2 million Indians every year. According to a report from WHO, about 80% of the city inhabitants were revealed to the air quality levels exceeded WHO particularized limits. A WHO study in 2016 found that 14 of the 20 world's most polluted cities belong to India. The city with the highest PM 2.5 level is Kanpur in UP. Hence, air pollution is one of the most alarming concerns for us today. So, by predicting the value of harmful pollutants even for next 1 hour or 2 hours with the help of IoT sensors and machine learning techniques, one can provide the citizens with precautionary measures. One can control the global warming. The government of India has reacted to the air pollution with a nationwide program. Coming to the next slide, the literature survey. In the first paper, the researchers have used four advanced regression techniques. The parameter PM2.5 is selected for air quality prediction. Random forest regression was selected as the best technique as its processing time was found much lower and its error rate was found to be the least among all four techniques. In the second one, they have used LSTM and SVM. The parameters ozone and nitrogen dioxide are selected. Obtained results show that the employment of LSTM-based prediction model is effective, promising, and gives prediction accuracy than SVM. In the third one, they have used RNN, feed-forward neural network, and multiple linear regression. Parameters PM10 and PM2.5 are selected. The comparison of the three methods show that the recursive neural network model has better performances in all the simulations. In the fourth one, they have used long short-term memory neural network extended model. The parameter PM2.5 is selected. The results show that LSTME model is superior to the other statistics-based model and also the use of auxiliary data improved model performance. In the fifth one, they have used non-parametric kernel regression technique. The parameters they have used are the variations in NO2 and correlation between the meteorology and NO2 levels to predict the air quality. The model was found to be an accurate and efficient means of spawning real-time air quality forecast. And the sixth one, they have used multiple linear regression technique. The parameter they have chosen is O3. The outcomes of this study highlighted that the existence of NO2 and sunshine affects the concentration of O3. In the seventh one, they have used CNN and LSTM. The parameter PM2.5 is used. The experimental results show that it improves prediction performance compared with classic models. In the eighth one, they have used transfer learning bidirectional long short-term memory model. The parameter PM2.5 is used. The results show that the proposed model has smaller errors, especially for larger temporal resolutions. In the ninth one, they have used logistic regression, random forest regression, k nearest neighbor, decision tree regression, and SVM. The parameters they have used are PM2.5, PM10, NO2, SO2, CO, ozone, and NH3. The results have showed that decision tree algorithms have better accuracy for predicting air quality. In the fourth one, they have used BPNN and ICA. The parameters PM2.5, SO2, NO2, CO, and O3 are used. The experimental results show that the developed early warning system is promising in terms of pollutant forecasting and assessment. In the 11th one, they have used MLR and feed-forward neural network. The parameters they have used are NO, NO2, O3, and also many meteorological factors like temperature, relative humidity, so on. The results depict that the feed-forward model gives more accuracy as compared to MLR. In the last one, they have used STCNN, LSTM, the spatial temporal convolutional neural network, and LSTM. The parameter PM2.5 is used. The model is verified to better adapt to the characteristics and forecast the air standard more accurately, which is more suitable and reliable for the field of air quality. Now coming to the next slide, proposed methodology. In our work, we are using regression. Regression is a machine learning algorithm which is based on supervised learning. A regression model consists of the input and output variables. Input variables are the independent variables which are used to forecast the value of the dependent variables. Output variables are the dependent variables. Output variable is also known as target as it is targeted by the independent variable to predict the outcome. The main objective of the regression model is to build a relationship between the dependent attributes and the independent attributes. The independent variable is denoted by x and the dependent variable is denoted by y. Regression models that we are using in our study are multiple linear regression, support vector regression, decision tree regression, and random forest regression. Now comes the multiple linear and the support vector regression. Multiple linear regression is basically an annex of a linear ordinary least square regression that uses just one explanatory variable. It is very beneficial for resolving the regression problems. Coming to the working of multiple linear regression, the key algorithm separates the historical data into independent variables and dependent variables and finds the relation between those variables. This regression model includes 5 modules, namely acquiring historical sample data, and then by establishing the equations of multiple linear regression, the regression coefficient beta is estimated by the least square method during the learning process in the training phase to identify the features that have high impact over the output y. Higher the value of the coefficient, the feature with respect to that coefficient has highest impact on the dependent variable and is considered as the most important feature for predicting the value. Once the model is trained, it can make predictions. Predict method is used on the model and X test is passed as a parameter to get the output as Y predict, and then the prediction output of the pollutant is shown by the model. Evaluation of the regression model performance shows the amount of accuracy in the results. Now comes the support vector regression. This algorithm is very useful for the prediction analysis. It only works with the continuous variables. This algorithm has been proven very efficient and effective in the real value function assessment. The key components used in SVR are kernel, hyperplane, boundary line, and the support vectors. Now coming to the working of support vector regression. In data pre-processing, the extraction of features and labels takes place. In the second, feature scaling basically helps to normalize the data within a particular range. It also helps in speeding up the calculations in an algorithm. In our work, standard scalar class is used for converting lower dimensional data to higher dimensional data and making prediction easier. Now, determining the kernel function and other optimal parameters is the important part in SVR. In our work, a radial basis function is used. As we train and test the SVR model, k-fold cross-validation is also used. Consequently, the optimal parameters can be obtained. So, by evaluating the performance of the model and by determining the best kernel function, the final SVR model predicts the output. Now, coming to the next slide, the decision tree regression and random forest regression. Decision tree is a decision-making tool that uses a flowchart-like tree structure or is a model of decisions and all of their possible results, including outcomes, input cost, and utility. Decision tree algorithm falls under the category of supervised learning algorithms. It works for both continuous as well as categorical output variables. The key terms used in decision trees are root node, decision node, leaf or terminal node, splitting, and pruning. So coming to the working of decision tree regression. Firstly, begin the tree with a root node say S which contains a complete dataset. Find the best attribute in the dataset using attribute selection measure to split the records. Make that attribute a decision node and breaks the dataset into smaller subsets. Start tree building by repeating this process recursively for each child until one of the conditions will match. That is, all the tuples belong to the same attribute value. There are no more remaining attributes. There are no more instances. And then we can call the final node as a leaf node. Coming to the random forest regression. Random forest is one of the most powerful supervised learning algorithms which is capable of performing regression as well as classification tasks. The random forest regression is an ensemble learning method which combines the predictions of multiple decision trees and predicts the final output based on the average of each tree output. Coming to the working of random forest regression, firstly, pick n random records from the dataset. Build a decision tree based on these n records. Choose the number of trees we want in our algorithm and repeat the above steps. In case of a regression problem, for a new record, each tree in the forest predicts the value for y. The final value can be calculated by taking the average of all the values predicted by all the trees in forest. Now coming to the next slide, the proposed model. In our proposed work, we want to predict the concentration of the pollutant nitrogen dioxide by using 4 different regression models, and the features taken in this study are PM2.5, NO, NOx, NH3, SO2 and O3. So firstly, to conduct the experiments, we have to take a dataset consisting of many meteorological factors such as temperature, temporal features such as the hour of the day, etc., and the pollutant concentrations. In this work, we have taken the dataset of Delhi of year 2019. In the second step, which is data pre-processing, we have to remove the irrelevant features or the features which we do not want in our experiments from our dataset. Third step consists of the extraction of input features and labels from the pre-processed data. In this step, we classify which attributes we want to take as input and which attribute will be taken as output. Features are the input. In this study, PM2.5, NO, NOx, NH3, SO2 and O3 are taken as input. Label is the output, the one whose concentration we want to predict. In this project, nitrogen dioxide is taken as output. In the fourth step, the splitting of training and test portions takes place. In this, we separate the data into training set and the test set, such as X test, Y test, X train and Y train, where X and Y are the input and output. In the next step, we apply our target regression model. In this work, 4 regression models have applied. Next step shows the output. In this, we get the output as predicted values of the pollutant from our target model. The last step consists of the evaluation of the regression model performance. By doing the evaluation, we will get to know the amount of accuracy in the results by which we can identify our best model. In the proposed work, R-square and RMSE are used. Now coming to the next slide, experimental results. This slide shows the prediction results of multiple linear regression. The figure 7 shows the actual versus predicted values by multiple linear regression, and figure 8 shows the scatter plot of actual versus predicted values by multiple linear regression. Scatter plots of actual versus predicted are one of the richest form of data visualization. These plots were used to determine a goodness of fit of the model. In a perfect condition, we expect that the points lie on the 45-degree line passing through the origin. The nearer the points to this line, the better the regression. The plot of actual versus predicted helps us to graphically see how well our regression fits on our actual data. In this figure, the blue line represents the actual values and the blue dots are the model's predicted values. Now coming to the next slide, prediction results of support vector regression. Figure 9 shows the actual versus predicted values by support vector regression. And figure 10 shows the scatter plot of actual versus predicted values by support vector regression. As we see in this figure, the maximum number of points are closer to the line and there are very less outliers. Now coming to the next slide, prediction results of decision tree regression. Figure 11 shows the actual versus predicted values by decision tree regression, and figure 12 shows the scatter plot of actual versus predicted values by decision tree regression. As we see, there are very less points closer to the line and there are more outliers. Now coming to the next slide, prediction results of random forest regression. Figure 13 shows the actual versus predicted values by random forest regression, and figure 14 shows the scattering of the actual and predicted values. As we see, more points are closer to the line and there are very less outliers. Now comes the performance evaluation. The performance evaluation of the algorithms shows the amount of accuracy in the results or prediction. In this study, R-squared and root mean squared error have been used as error criteria to evaluate and compare the models. R-square is used to measure the variation in the dependent variable which is explained by the independent variable. The value of R-square lies between 0 and 1. The more closer the value of R-square to 1, the better will be our algorithm. The RMSE is used to calculate the average magnitude of the error. It is obtained by taking the average of square differences between actual versus predicted values and taking the square root of the final result. Lower the value of RMSE, better will be our algorithm. As shown in this figure depicts a graph representing the comparison of R-square and RMSE for different regression techniques. This figure clearly depicts that support vector regression is the best technique among all the four techniques, performing well for the prediction of NO2. Its error rate is found to be the least among the four algorithms considered. And decision tree regression has performed the worst of all algorithms as it has given a very high error rate. Now comes the conclusion and the future work. This study has carried out the pollution prediction by using the regression techniques. The parameter NO2 has been chosen in our work. R squared and RMSE have been used as evaluation criteria. The simulation results show that support vector regression is the best technique among all the four techniques. Its error rate is found to be the least among the four algorithms considered. Decision tree regression has performed the worst of all algorithms as it has given a very high error rate. In the future, we direct our vision towards doing classification on the dataset by applying advanced regression techniques. Also, we will improve the accuracy of these regression models by choosing more appropriate features which have high correlation to the values that we are trying to predict. Furthermore, we also intend to investigate the other parameters affecting the air pollution. These are the references. This is my publication status. We have published one paper in the proceedings of IEEE 2020. Thank you.